In today's chemistry riddle, we will try to figure out an appropriate synthesis from this starting material, an isopropyl methyl ketone, to this substituted furan. So what is the first step in designing such a synthesis? Well, let us compare these two molecules and where do we find the framework atoms of the starting component within this molecule, this target molecule. Well, for some of you it might be easier to draw this a little bit different with a carbonyl group here and the methyl group on the other side, of course, here up. Well, now we can see the isopropyl group is here, then this carbon, there another carbon, and here the oxygen. So, this is the part of the molecule which derives from this starting material. And now we have simply to count what is left, or a 3 carbon unit, and that this carbon unit, 3 carbon unit, is able to react. It should not be simply propane, but it should be functionalized. And maybe the cheapest compound that we can find should be acetone. Well, let us think about using acetone here. Well, next step is we have to form a bond between this carbon and that carbon, and this means here this carbon-carbon bond has to be formed from here to there. Unfortunately, we have the same reactivity, and the natural reactivity here and there is nucleophilic reactivity by the formation of an enol or an enolate. So what we need is, well, in one of those cases, the opposite electrophilic, an electrophilic center, and therefore we are in need for a reactivity Umpolung. Well, we can do that simply here in our research plan, adding a leaving group X either here or there. So let us think about where should we put on that leaving group. Clearly here, because in that case at acetone we have 2 methyl groups, and here we have a selectivity problem. Would we be able to put in a leaving group here selectively while the enolate is forming preferentially to this side? Oh, this is a problem. We can address that problem by using a sterically hindered base, but this variant is much more easy. And what could be X? Well, it could be chloride, bromide. Well, with those two we should be very careful because that compound then is a lacrimator, and maybe something like that, a tosylate. So, what we should do then is deprotonate at typically minus 78 degrees dry ice temperature, and with a sterically hindered base we can selectively form the kinetically preferred enolate, and let this react with the electrophilic component. Then we have this 1,4-dione. So now under acidic reaction conditions, we can eliminate water. One enol is formed under the acidic conditions, and the enol hydroxyl group will attack the other ketone, and at the end all olefinic double bonds will be placed like this, because this is the thermodynamic sink, because this is an aromatic system. It's as easy as that. Thanks for listening.